Hi, good evening everyone. This is the 15th session of your class, the chapter number 5. The concept is the trees chapter. The next slide, let me know about what is the binary search tree. The binary search tree, it is a node-based binary tree data structure. So it has a sum of the following properties like the left subtree of the node, it contains only the node with the keys lesser than the node's key. And then the right subtree of the node, it contains only the nodes with the keys greater than the node's key. And the left and right subtree each must also be a binary search tree. So once again I'll repeat. So what is the binary search tree? So it is the node based binary tree data structure. So it has the sum of the following properties like the left subtree of the node, it contains only the node with the keys of the lesser than that node key. And then the right subtree of the node, it contains only the node with the keys greater than the node's key. And then the left and right subtree each must also be a binary search tree. This is the definition of the binary search tree. So this is a diagrammatic representation of a binary tree. Here the key node, that is a root node, it has a number 8. So the left subtree of the node, all the nodes which have the lesser than that of the root node, that is lesser than the values of that value is an 8. And the right subtree, it has the number of the key nodes, that is all the greater than that of the key node, that is a root node. So that is 8 is a root node. The left subtree, it has a numbers like 3, 1, 6, 4 and 7. The right subtree, it has a values of the node like 10, 14 and 13. The next concept is array representation of tree. So it has a binary tree. Talking about this representation, the trees can be represented in the two ways, same as like a stack and queue, same as like that. Here also it has a two representation of an tree. One is a dynamic node representation, that is also called as a linked list representation, and the second one is that array representation, that means the sequential representation of the tree. So the concept is the tree traversal. This is very important. So tree traversal, it has the three different types of a tree traversal: in order traversal, pre-order traversal and also post-order traversal. So before going to a traversal techniques, it has a two different types of a traversal. One is the depth first traversing techniques. Depth first traversal technique. So here is the in order technique, that means the left, root, right. The values which are the first in the in order technique, that is the values are, first we can go to the left, that is a 1 is a root node, that left node is a 2, the another left node is a 4. So that first we have to return the value 4, then go to the root node, that is 2, then right, that is a 5. The left subtree is finished, then go to the root node, that is 1, then the right node is a 3. So that the in order depth first traversal technique, the values which are 4, 2, 5, 1, 3. Then the second is pre-order. So pre-order techniques, that is root, left and right. First we have to write down the root value, then the left value and also right value. So the root value is a 1, then go to the left, that is also subtree root node, that value is 2, that is written. Then go to the left node, that is 4, then right node we have to return the 5, then the last node, that is a 3. Then the post order traversal, that is value that written by using the left, right and root nodes. So that the left node is a 4, and then right node is a 5, then writing the root node, that is 4, 5 and 2. Then that is left subtree is over. Then go to the right subtree, that is a 3. Then the last is root node, that is 1. So that it is finished in order, pre-order and also post-order. Then the second traversal is a breadth first search. The values which are 1, 2, 3, 4, 5. So that is side by side. The first traversal technique is an in-order traversal. Already we know that what is an in-order traversal. That is the values which are in order is that. So here the left, root and also right. So algorithm is that first we have to traverse the left subtree. That means we have to writing the left subtree. Then go to the root node, that is visiting the root node. Then go to the right subtree. Same here is the algorithm of the in order tree technique, which is that traverse the left subtree, that means call the in order left subtree, then visiting the root node. The third step is that traverse the right subtree, that means call the in order, that is the right subtree. The second is pre-order traversal. Here also the algorithm is there. The pre-order traversal, which means that left, so first we have to write in the root node, then return the left subtree, then return the right subtree. So here also the same is that the first step is the first we have to visiting the root node, then go to the traverse the left subtree, that means call the pre-order of the left subtree. Then third is the traverse the right subtree, then the call the pre-order of the right subtree. The next is that post order traversal. So post order traversal is left, right and root node. Here is the algorithm. The first step is traversing the left subtree, that means call the post order left subtree, and the second is the traverse the right subtree and they call the post order of the right subtree. Then third is that visiting the root node. That this is the algorithm for the post order traversal technique. So this is the end of this session. So thank you. So here the syllabus has also been completed here. Thank you.